Today we're looking at our third type of transformation, which is rotations. Now, just like our previous two transformations, translations and reflections, a rotation is also an isometry, which, remember, that's when the pre-image and the image are congruent. So the size doesn't change, the shape doesn't change in a rotation. And it's an isometry that turns a figure around a center a certain number of degrees. So it's pretty straightforward. I mean, you guys know what it means to rotate something. You're just kind of turning it. Now, therefore, in a rotation, since you're turning it a certain number of degrees, you need to know a couple things. You need to know the center of rotation, which is a point. Which point are you rotating the shape around? You also need to know the angle of rotation, so how many degrees you're turning it. And you need to know the orientation of the rotation. And what they mean by that is you need to know, are they rotating this figure clockwise or counterclockwise? Now, it's important to note right here, and it's starred, and honestly, this kind of seems backwards to me, but this is how it goes. Unless it's stated otherwise, you're going to always assume that rotations are counterclockwise. Which, personally, it makes more sense to me if it's assumed that we go clockwise, but we're going to do backwards thinking today, which I know, that makes total sense. So, unless they tell you, hey, it's going clockwise, you assume that they're turning it counterclockwise. Okay, so think of the hands on the clock, go the other way. Now, really, there's only one example that we're doing, and all of the rotations that we do are similar to this. So our example is a regular, we'll talk about that, a regular pentagon. So it's got 5 points, 5 sides, and we're going to answer the questions about this one pentagon right here. They want to know what's the center, so what's the point that we're rotating this shape around. Well, it's just going to be the center of the pentagon, which is point O. That's going to stay still, and we're going to turn the shape around that point. Now, here's where we really get into it. If I map A onto P, so if I map A onto P, what is the angle of rotation? And remember, if they don't note it, so this is kind of why they're reminding you, if they don't note it, we assume they're going counterclockwise. So they want to know how many degrees would I have to turn this thing counterclockwise to land on P. Now, here's how you figure out how many degrees each turn is. 360, so here's my little, yay, here's my pentagon that we're rotating. If you rotate this thing full circle all the way around so it lands on itself, that was you rotating this 360 degrees, full circle. Now, you need to figure out, if I just turn it one turn, where it kind of lands in the same position, there's 5 of those that happen to go full 360. So since it's regular, each one's going to be the same. So if I do 360 divided by 5, that gets me 72 degrees. So every turn where the pentagon kind of lands on itself is 72 degrees. So I want to know how many times do I have to turn it so A lands on P. Well, let's see, 1, 2, 3, 4 times for A to land on P. And most of you could just count that, 1, 2, 3, 4. So since each turn was 72 degrees, if I multiply that by 4, that's 288 degrees. So that would be my answer for the first part of number 2. Then it asks me, will rotations always have this degree of rotation? Will it always be 72 degrees that I'm turning a shape? And that answer is definitely not. This is only applying to a regular pentagon, the 72 degrees that we came up with. Since this pentagon is regular, that means that the number of degrees between the vertices is the same. Okay, so all of these angles are the same, and we already figured that out. That was 72 degrees. So that just tells you how many degrees you're turning it each time. If the shape that they gave you was an octagon, well, that has 8 sides, so you'd do 360 divided by 8, and each rotation would be 45 degrees for a regular octagon. So just be aware that depending on what shape you're looking at, that's going to determine how many degrees your turns are. Now example 3, or number 3 says, find the image, so where would I land? What's the image of A when the figure is rotated clockwise 144 degrees about point O? Here's the first thing I do. I want to figure out how many times am I turning it if it's going 144 degrees. So we already established that each turn was 72. So you're going to turn this 2 times. And let's see, we're going to start at A, find the image of A when it's rotated clockwise. So we want to go this way. I want to turn it clockwise 2 times. 1, 2. I would land at K. Don't you like my little pentagon here? It's fun. All right, number 4 says, what's the image of F? So where would F land if you rotate it 216 degrees about point O? So same thing. I'd figure out, all right, well, how many turns is that? Well, this time it's 3 turns. They did not say, so I'm assuming counterclockwise. So if I start at F, counterclockwise would be this way. I need to go 3 points. So 1, 2, 3. That would land at P. Number 5 says, describe the rotation that would map K to W. And they want me to describe it 2 different ways. That means one way clockwise, one way counterclockwise. Or I could guess, I could just like turn and go around and around a lot of times. But I'll do one clockwise, one counterclockwise. So here's K, I want to get to W. So they could just make it go 1 turn to the left, which would be clockwise. So I could go 72 degrees clockwise. If I wanted to go counterclockwise the other way, I'd have to go 1, 2, 3, 4 points, which would be 72 times 4, 288 degrees counterclockwise. You could always turn more than full circle, but those are just a couple examples. Number 6 says, what's the image? So where do you land PK when the figure is rotated 1 turn about point 0? So here's PK. And I want to know, it doesn't say, so I'm assuming it's counterclockwise. If I go counterclockwise 1 turn. So I would go this way. And PK would be right here, which is AP now. And the last one says, what's the image? So where would it end up? Point W, where would it end up if it's rotated 360 degrees, which I should know that that's full circle. So if I want to know where W lands after I go all the way around, you're just going to land right back where you started. So it'd be point W. All right, so that is rotation. That's all we got here, and that's it.